feels weird because this is the most well-lit video I've ever made for this class. So I have no idea if this is going to look... I have no idea if this is going to look nice or not. I'll have to rewatch this. At this point, I am my own guinea pig. So I have a few things I want to just play around with. We'll see what happens. Apparently throwing a lot of light on yourself is supposed to be really good for videos. It makes weird shadows in the background, but I know I've had a lot of issues in this class with my camera zooming in, zooming out, zooming in, zooming out. So we'll see if some of that is fixed by adding more lights. Certainly doesn't make my skin complexion look any darker. But I haven't gotten a tan in ever. Okay, so what we're going to be talking about in class today is the idea of design selection. You may have seen in your readings for last week, or in the diagram that was shown on the very far left side. I think it's weird. I got a light at my back. The diagram of the far left said, hold on, I actually have it pulled up. Discover design projects. Discover design projects. I guess I should name the lecture up here. But there were three inputs that led into this. One of them was a technology push. One of them was a market pull. And the last one was the product change. Okay. When it comes to design selection, there are three real big reasons why anyone goes through a design process. And it's these three. I think it defines it very well. I like what David Ullman does in framing it that way. What you have here is these three different types, and I'll explain them to you. So what a technology push is you have scientific developments, new knowledges, new ways of handling materials, new material sciences, new algorithms. You have new computational science theories. I mean, we are constantly developing our state of knowledge, and what happens from this is that these scientific developments at some point cease to be theoretical recognitions and begin to become concrete physical systems. Okay, and this is where either you'll have the theory of some face recognition software gets turned into an algorithm where faces can now be recognized, and now from that could be that is a major development where now we have the algorithm and we can plug that algorithm into anything you want. You may have a brand new type of concrete. They just recently created an electrically conductive concrete, and the goal is that if you plug the concrete into a power outlet, it would melt the ice off of it so that you don't need to cover it with rocks, and you don't have to throw a bunch of salt on it. All of this starts as a theory, comes up with a physical product, but once it becomes a physical system, then you can take that physical system and plug it into realistic designs. One great example of this is the touchscreen. When the touchscreen was really revolutionized by Apple in the production of the iPhone, it started out as a theory of, hey, could we do capacitive touch? They came up with a method of doing it. They had to refine that method. They came up with a screen, and then they found an application for that screen where it was actually plugged into a phone. You see this in industry all the time. Somebody comes up with something brand new. You take, as a kind of a dumb example, the Game Boy Advance. First Game Boy system that featured a rechargeable battery that wasn't awful. It used lithium-ion batteries. The lifespan on those things were forever. Little boxes. I mean, you could just plug one in and you could play for days. It helped that the screen was super small. But they found that, better technology was capable with lithium batteries. They developed with the lithium batteries, and then plugging those lithium batteries into the Game Boy Advance made the Game Boy Advance actually very popular. It was by far the most popular handheld device at the time. It really pushed out all of the other markets, and it really cemented Nintendo's hold in the portable console market. So another example, just drawing on my video game past here. But technology push happens a lot. We develop new technology, and how we use that new technology can enable us to really jump into some very unique markets. Okay? But you also have on the other side the idea of a market pull. Now, the process for a market pull is this could happen in a number of ways. Whereas this was fairly linear, it has to happen this one, this one, this one. There are a number of different ways that a market pull can occur. Okay? First thing, you have competitors leave the market. Okay? An example of that is, say, all of a sudden McDonald's, Burger King, they stop deciding to sell hamburgers. Okay? Now, I am a hamburger kind of guy. I go to places because I crave hamburgers. Like, give me some of that slab-o meat, slap it on some of that sauce, nom nom. Okay, that's life to me. If all of a sudden McDonald's, Burger King stopped producing hamburgers, you would see, and you throw in Wendy's in there, you throw in Hardee's, you throw in Freddy's, you throw in Culver's. I mean, you take out all the major restaurant chains, everybody stops selling hamburgers. What you would see is a void where, a guy like me just wants a burger. Where would he go? Well, unfortunately, it leaves a lot of the sit-down restaurants like Red Robin, and all these other places, and I don't really want that. These local shops that may deliver hamburgers would suddenly become really advantageous, and it becomes an opportunity where they would put together a marketing plan and say, hey, let's take advantage of the fact that there's nobody else selling burgers in the area. Oftentimes, what you may have happen in industry is, let me think of a good example. But there's times where competitors just simply say, well, we're done selling this product. We're not seeing very high sales on it. We're just gonna nix it from the market, and then it's impossible to find those anymore. It happens a lot more. I can't think of any example off the top of my head, but I know it happens. And when it happens, it produces an opportunity, because what you have now is there's no products there. Nobody is majorly contributing to that product, which means there's now a void that you can fill. You can step in, and a company who may not have manufactured, say, since I'm staring into so many LED lights, they may not have manufactured stand-up lights. Seeing a void in the market where major competitors have decided to step away, they may jump in and now say, well, let's make these products, because there's a market for it and nobody's filling that market. Okay? So competitors leave. New markets are found. Okay, this may mean a number of things. First of all, you may come up with an idea that is brand new, novel, nobody's ever sold it before. As an example, I know a few years ago there was a lot of concern with football player helmets not being safe enough. So you have major companies like Rydell, have traditionally put together a lot of football helmets, and now it's not very safe. Well, somebody comes up with a brand new product, a brand new safer helmet, which a number of companies have. There's a new market for that product because nobody else sells a safer helmet. You go look at industrial robots. The term cobot is a big deal right now because cobot stands for a collaborative robot. It's a robot that's intended to exist in the same environment as a human. Cobots were, you know, traditionally it was just, well, you get murdered by a robot while you're on the job. That's why you have to put a cage around the robot. Robots were just dangerous. In today's world, we don't like the fact that there's equipment that can just simply murder people. There are still people being killed by industrial robots. I believe there's 2 or 3 incidents that happened last year where they got into a cage with a robot because they needed to pick up something, or there was a device that was in there and the robot arm swung around and decapitated them. It's a dark world, but it's still happening. It's still happening in today's world. And we like to talk about how automation is great. Automation kills people too. Unless you do it safely, and which is where cobots come into existence. Cobots have the ability to sense their environment, sense if they're actually near people, sense if they're impacting people, and then stop. And they will actually shut down operation entirely. And that's the beauty of these cobots. So when cobots first hit and you say, hey, we have a robot that won't murder you when you climb in there, there was a new market for it, and it was beautiful. When vehicles decided to come up with the technology for the lane assist and parking assist and brake assist, all of these different things, there was a new market for it. Nobody had come up with it at the time. Whoever created the algorithms for it, I mean, you patent it, you sell the algorithms. It's a new market. Nobody else had come up with it before. And they have the ability to do that. So a lot of this is, if you have brand new technological development, this is it. Now, this is what a lot of people tend to think engineering is. Coming up with brand new stuff that's never been done before. Yeah, but you also have this, you also have this, and there's a lot more other things too. Sometimes what you have is that you have a volume expansion, okay? This last year was a great example, 2020. In 2020, you saw a just gigantic demand for toilet paper, hand sanitizer, and PPE materials. Okay, you'll have companies who traditionally haven't ever created PPE materials. Suddenly they're putting together ventilators. Suddenly you have companies who have never put together PPE materials producing nylon gloves, producing masks. You have a bunch of people who just suddenly create masks because it wasn't a brand new market. It was just that there was an increased need for that product. And as a result, a lot of companies changed, and you have breweries that are out there producing hand sanitizer because the formulas are fairly similar. Both of them use alcohol. I do like that burn when I put it on my hands. It's therapeutic. But this is what a market pull is. Every once in a while, something happens in the market. Whether that be you come up with something brand new, whether that be the demand increases, whether that be the competitors just simply leave, the supply reduces. Okay, I should write that too. Supply reduces, demand increases. And here, more than likely, if you were buying your own toilet paper last year, you ended up buying some pretty poopy materials. I apologize. But it's because you have people who didn't know how to manufacture toilet paper just making it. And they could, and they were helping out the market. They saw a need, they filled the need, they earned a little bit, and they helped satisfy the consumers. And we all got terrible products as a result. Okay, so that's the market pull. The last one is a product change. Okay, let's say you are an automotive manufacturer and you decide, you have to buy tires every year. Well, all of a sudden, one year they decide, well, we did a stress analysis and we actually need to move the lug nuts out 1/2 inch. Well, that poses a problem for you because all of your systems are designed to have, 6-inch diameter lug nuts. And now all of a sudden you have 7-inch diameter lug nuts that you have to accommodate for. You have to get different axles, you have to get different mounts, you may have to use different screws. It's a huge amount of design work that's needed to accommodate for a different product that's being put out. Now, there are a lot of things that motivate product changes. Some of it is increased efficiency. We found that we can use, if we change the product slightly, we can use 3 screws instead of 4, and it does the same. It makes it easier to maintain, makes it easier to produce, make it happen. It increases the efficiency of the system, the efficiency of how it does its own thing. And that's one. You may have change in supplier. If you buy a certain type of circuit board from a certain type of supplier, and all of a sudden the next year, well, you buy it from a different supplier, there's going to be different hookups, and it's going to require different tooling, it's going to require different wiring. It may require you to redesign your device entirely to accommodate for the different hookups, just because you changed vendors. So there are a lot of different ways in which this can affect a design. And lastly, you may also have an issue where you come to a greater scientific knowledge. Great example of this one is asbestos. Asbestos is cancerous. Boy, it was a great engineering material while it lasted. But it's cancerous. And if you come to understand that, oh heck no, that's cancerous, you're probably not going to use that in a lot of designs. And it becomes toxic for you. And so then it's, okay, how do we find a material that's similar to asbestos, that is not cancerous? And this spurred on a lot of polymer and plastics designs, rubbers designs, something to try to come up with this, a lot of different foams. Society is still actually, interestingly enough, trying to find something as good as asbestos. Companies are still trying to find a refrigerant as good as Freon. R134 is pretty good. It's really good. But it's still not as good as Freon. Freon is still better. Freon destroys the atmosphere. But apparently that matters more. Apparently having an atmosphere matters more than having a cold beverage. I go to my refrigerator and I'm like, man, I need a soda, but I don't want to destroy the environment in the process. It's the little sacrifices we make. I say that entirely facetiously. But all of these are good reasons to design something. Okay? Only one of these involves brand new technological development. All of the rest of these are just simply the fact that there is a need for design. And you will, as an engineer, you will deal with probably all of these at some point. If you're more civil engineers, you tend to deal with a lot more of this type of thing, where you're building brand new types of buildings, different materials. And I guess you're building brand new buildings, structures, whatever, maybe optimizing things, increasing efficiency, that kind of thing. But most everybody else is dealing with the other types of design. So this is all of the reasons why you would jump into a design. Now, how do you actually pick what design to jump into? Well, that gets a little bit more challenging, so to speak. And this is really where we get into, how do you make design decisions? Okay? When do you decide when to pursue an idea? And what I'm going to go ahead and throw out is, I'm going to give you 2 different options for how to do it. There are much more than 2, but these were put together specifically to help decide whether or not to initiate a project. Okay? And the 2 are a ProCon analysis, this is covered in the book, and a SWOT analysis. Okay, so what is a ProCon analysis? Well, it's really simple. I'll give you an example. All right, so I just mentioned beverages, now I'm really thirsty. Man, I could go for a Mountain Dew. However, cans of Mountain Dew are inconvenient. They're not reclosable. I mean, you could buy stuff that makes them reclosable, but they're not really reclosable. Plastic bottles, while they are nice, I mean, they pose an environmental issue because this plastic doesn't degrade as well. Aluminum actually does degrade fairly well, so if you throw out an aluminum can, it degrades a lot better than plastic. Regardless, I mean, plastic bottles, it doesn't store for very long before it loses its carbonation, whereas a can is much better at keeping the carbonation. So let's say, as a solution, I want to make a brand new kind of beverage container that is consistent of a composite. Okay, it's a resin-like material where what we've done is we've sealed the outside with a plastic-like material. Excuse me. And on the inside, we retain the metallic sort of, the seal that prevents it from losing its carbonation. Okay, so I've come up with a new bottle for my soda. Because man, am I thirsty. Okay, pros to this. The nice thing about this is it improves the quality of the drink. Nice. I like that. As a consumer, I love high quality drinks. We can also design this to be a lot more robust, which means we lose less product. Okay, when these bottles are dropped on the ground, they don't explode. No, we just make them using the processes of a bottle mixed with the processes of making an aluminum can. Bada bing, bada boom. They're more robust. Save money. So we're saving money because we're losing less product, and we're improving the quality of our product. Well, heck yeah, let's do that. Well, there are a couple of problems associated with it too. Every new design also has a number of cons to it. Got a bunch of pros, bunch of benefits, but it also has a bunch of drawbacks. Drawback is new design process. Okay, anytime you do something brand new, it's going to take a new design process. Another problem here is this is probably going to be more expensive. Another problem here is while you are using both plastic and metal, they may not interface well. You're going to have to look at a new kind of sealant. It's going to involve probably changing up what type of plastic and what type of metal you're using, which means you're going to have to get different suppliers. Okay. And then lastly, you may have that consumer pushback. There's always a barrier to entry for any product. If you're a brand new company, if you're a company like Mountain Dew, they don't have a lot of consumer pushback. You can sell, you can sell underwear with the word Mountain Dew on it. People would buy it just because it has the word Mountain Dew on it. It doesn't matter if it's made out of pure wool. Like, oh yeah, got my Mountain Dew undies. Heckin' yeah, PS 2021. You're gonna have some consumer pushback there. For most companies. Companies like Apple, they can just produce whatever they want. But there's always gonna be a barrier to entry for most products. Even if it was wool panties with the word Mountain Dew on them. There's always a consumer pushback where the consumers are not ready for a brand new market to exist. So there you go. There's pro cons. Now SWOT analysis is a little bit more involved. Okay, SWOT analysis it involves understanding a bit more. Pro-con analysis is very simple. Ultimately, if the pros outweigh the cons, then yes, you make the decision. If the cons outweigh the pros, then yeah, you do not make that decision. In our example there, you know what? We would try it. If we have enough money as a company that the cost of producing these is not substantial, we would try it. You know, do a very short test market. Try the product, see if the product does actually make it better. Because if the pros are proven true, in today's culture, people are more willing to pay more money for something that's going to store forever. It's not all about like, oh man, you know, I can get these plastic bottles, but plastic bottles will probably open them and they'll be flat, but I can get these brand new carbon fiber bottles and they're going to look pretty spiffy. Be pretty tasty. So the SWOT analysis, SWOT analysis stands for strengths, weaknesses, opportunities, and threats. Okay, a little bit more than just a pro-con. You could say that this side is pros and this kind of side is cons. But there's a little bit more to cons than just drawback. Everything has there's a difference between a weakness and a threat. And there's a difference between a strength and an opportunity. An opportunity may open up new avenues, whereas a strength may be directly applicable. Opportunities are looking to the future, threats are also looking to the future. Okay, whereas strengths and weaknesses are kind of looking to the present. So if this side is pro and con, this is future and present for rows. And that's really how the SWOT analysis is set up. So let's pick a different design topic this time. Let's say we're going to design a brand new, oh, not that one. We're going to design a brand new jet ski, okay? Let's say we work for a company that produces small fishing boats. And you know what? We're going to step out and produce a jet ski this time, okay? Now the strengths here is if you're a well-known fishing boat manufacturer, you do have some brand loyalty where you have some consumers that will just simply buy whatever you put out. And this opens up a new market so that you're not just a fishing boat manufacturer now. Yeah, you are an aquatic vehicle manufacturer, and that's a big leap. It is. It's a big leap for a company when they decide to jump into a new market like this. Okay, you know, some people just simply buy it because it's interesting, because it's cool, because they've bought fishing boats from that company and they trust that company. Okay. Opportunities here too is a lot of the treatments and a lot of the materials used for these vehicles are already available to you. You buy the body of a boat, you buy the body of a jet ski, they're going to be very similar materials, different coatings, same coatings, same painting, same needs for those materials. Okay, so that is a good thing. If you're a fishing boat company looking to jump into the jet ski market, you do have already some benefits there. Okay, and the nice thing is too about this, you can actually make this so that your jet skis can learn from some of the things you learn from with boating. Can learn from what happens when you hit things. So if your company excels at making boats that run into stuff, you can make a jet ski that can handle running into stuff. And that is a new market. That is a new, novel way of approaching this market. Now the weaknesses here are motors are going to be different. Okay, the motor on a jet ski tends to be a much higher power engine that shoots out a jet of water. You're also going to be dealing with different dynamics in the water, different speeds. And that does impact things. And you're also going to be dealing with a different user interface. It's not just turning a rudder anymore. Now it's, you know, pushing a button, turning handlebars. It's what people are used to when they use jet skis. Now, the opportunities that are offered by this are more aquatic vehicles, apply patents appropriately. If you have patents in impact prevention or mitigation or energy absorption, yeah, you're going to want to use those in more than just one area. I mean, it applies to a broad reach of aquatic vehicles. You might as well go use your patents elsewhere, which creates a brand new market for you. Okay? And that's opportunities. Now, your threats here are you have well-established vendors. Competition. You have jet ski. I mean, you have a couple of other companies that are they're very large. They've been selling them for decades. And you want to jump into that market, well, it would require a lot of work. It's a threat. They could overwhelm you and end up removing your ability to produce for that market. Okay. Another threat is going to be that the materials are different. You could be looking at potential litigation. If you don't understand the market well, there are lawsuits that happen because of jet skis all the time. People get hurt. So that is a threat. Now we could sit here all day and continue to add to multiple lists. That is a made-up company and a made-up product, so we're making some assumptions here all the time. But this is how you would do a SWOT analysis. What is the immediate strengths? What is the immediate ideas that would make producing this good? There's a market for it because we have patents that apply. There's materials and suppliers available, so we can make them right away. There's no barrier to waiting to figure out what those are. And we have customers who are willing to buy anything aquatic we have. Maybe this came from doing surveys. Immediately, we're going to have to get different motors. We're going to have to understand different motors. Immediately, we're going to have to study water dynamics. Immediately, we're going to have to operate off of a different user interface. It does produce a lot of interesting problems. But at the end of the day, if you ask me, to this company, it would actually be a good idea for them to go ahead and pursue it because this column outweighs this one. So, that's a design selection. You will be expected to do a SWOT analysis in Project 2, so keep that in mind. I'm going to go ahead and get into AutoCAD, so that's it for this lecture, and